Hello everyone, I am Harpreet Singh from DSA Batch 6 of Girl Script Winter of Contributing, and the topic for today's presentation is circular queue. So we will be discussing in detail what is circular queue, why there is a need of circular queue, and how can we implement using arrays in Java. So let us start. So let us talk about what is a circular queue, right? So before talking about what is a circular queue, let me see the limitation of the linear queue. So in linear queue, when your spaces were empty and your rear reaches the last index, then you can't use these empty spaces. That was the case in linear queue. So that is a disadvantage. And the circular queue comes into the picture, which overcomes this disadvantage. And what it do is after the last index, zeroth index will come. So basically, the last index is connected to the zeroth index, as you can see here in the circular queue presentation. And what will be its use? That after your rear reaches the last index, then also we will be able to insert the values here as well, here and here. So no empty spaces will be left, and circular queue will overcome the limitation of linear queue. And circular queue is also known as ring buffer, as it is forming a ring. Okay, let us discuss in detail what are the operations done on a circular queue. So we have discussed that the last index will be connected to the zeroth index. After that, let us discuss what are the operations. So if you talk about the operations, there are four major operations. Front. Front will be pointing to the element which is going to be deleted, right? The deletion takes place from front, as we know. Okay, so it will, if the queue is not empty, then it will return me the value pointed by the front in the array, in the queue, right? Rear. Insertion done from the rear part, and if your queue is not empty, it will return me the value pointed by the rear pointer in the circular queue. Then comes the enqueue operation with the value as a parameter. So basically what it do is it will insert the value inside the circular queue by circularly increasing the rear pointer, that we will discuss in detail. Dequeue operation, it will return me the value which is deleted, and it will also circularly increase the front pointer, and we will discuss it in detail, right? Let us see some applications of a circular queue. So circular queue, as the property it is carrying, that the last index is connected to the zeroth index, so it can be used in memory management, CPU scheduling, and traffic system. Like if I give you example of traffic system, what happens is uh, red light is there for stopping, then yellow light for initiation, and then green light for going. After green light, again comes the red light after interval. So this is what we can see is a circular queue, right? Like after the green light, red light comes. Okay, and similarly CPU scheduling and memory management, these types of things will be happening, and which will depict the nature of circular queue. Okay, let us discuss about the enqueue operation now. So if the queue is full, then you don't need to insert anything because you don't have any space to insert, right? So you can just say it is overflow condition and you can exit the function. Otherwise what you can do is you just need to circularly increase the rear index by 1. And what do I mean by circularly increase? It means that after the last index, it will come to the zeroth index for inserting. How it is done by the syntax, we will discuss it in menu driven program, right? And then when you will increase the rear pointer, like in the initiation, the rear pointer will be pointing to -1 and front pointer will be pointing to 0. If I come with the value 10 to insert, rear pointer will circularly increase and point to 0th pointer, and then I will add the value that I want to add, that is suppose 10. And then yes, my front will be pointing to 0 and rear will be pointing to 0 after the first insertion. And similarly, if I want to insert more elements, then my rear will increase and I will insert one more element. Rear will increase, I will be inserting one more element. So if I insert all the elements in the queue, then it will be looking like this. That front is pointing to 0 and rear is pointing to 4. Let us discuss about the dequeue operation. In the dequeue operation, if my queue is empty, then I can't delete anything, right? So I will be saying that this is not the condition and you can just exit the function. Otherwise, you can just return the value pointed by the front and circularly increase the front index by 1. Let us see here in this example, like front is pointing to suppose 2 index, that is the value 30. So it will return me the value of 30 and front will start pointing to 3, right? And this will be the case in DQ operation. Okay, so here you got the complexity analysis of the circular queue. So take a pause and uh, think yourself that what will be the complexity for a circular queue, the NQ and DQ operations. So yes, you are right that it will be a constant time. Okay, because for deletion what you are doing, you are just returning the value pointed by the front and circularly increase the front pointer. If you want to insert a value, then what you can do, you can increase the rear pointer and then you can just add the value. So these are the constant operations, so it will just take big of one time complexity in array implementation. Okay, so let us talk about the menu driven program for the circular queue. So here is it. Yeah, first of all we will be importing the scanner class for taking input, and then I can make the scanner object scn. After that I will be making my circular queue class, which will be having all the functions of circular queue that I want to implement. Then I am having a private type array, which will be a circular queue, and I'm having the pointers front pointing to 0 and rear pointing to -1 as we have discussed. And we will be having a size. Why size? Because how much the size is in between, that I need to track, right? So for tracking I will be maintaining a size. Then in the constructor of my circular queue I will be having a user defined value, and according to that I will be initializing my array with that size. Then in the enqueue operation it will be returning boolean type. Why? If the enqueue operation is successful, then it will return true, otherwise it will return false. So it will return false in the case of when the queue is full. So if the queue is not full, I can just circularly increase the rear pointer. And what do I mean by circularly increase? Let us take an example that rear is pointing to 4 and 0th position is empty. Then at 4 rear, it will do 4 plus 1, that is 5. 5 modulus array dot length. Suppose I have given it 5 only. So 5 modulus 5 will be 0. So after 4th index, after the last index, it will start pointing to the 0th index. That is why we have used this logic. And you know that when the array dot length is more and rear this thing is less, numerator is less, then whatever the numerator is, that value will be there. Like if my array dot length is 5 and suppose rear is at 2 and I need to insert at 3 index, so it will do what? 2 plus 1 3, and 3 modulus 5, what will be the answer? 3 only. So it will not harm me in any case, and it will serve the purpose of circularly increase. So it is important to understand, right? So then at the rear position of array you can just insert the value and you can just increase your size by 1, because you have added the element, so you need to track the size as well and return true if the case is successful. Then we have the DQ operation, which will be returning integer type value. And if your queue is not empty, then what you will be doing is you will be getting your element out from the array of front. You will take the element, then you can circularly increase the front pointer as we have discussed in the case of enqueue operation, the rear pointer. Similarly the front will be behaving, and then I will decrement the size and it will return me the element which has been there. If suppose the queue is empty, then I will say that return -1, which will be showing me that the queue is empty and I can't perform any DQ operation. That is a underflow condition. Okay, in the front as well I will be saying if it is empty then return -1, otherwise give me the value pointed by the front. In the rear pointer, if it is empty return me -1, otherwise give me the value pointed by the rear pointer. In is empty, what we are doing, as we are using it a lot of times, we are just tracking the size that we have maintained. So here you will get to see why we were maintaining the size, right? In enqueue operation we were increasing the size. Here in DQ operation we were decreasing the size. Why is it so? Because for telling that it is empty or not, I will be saying that if my size is 0 then it is empty, and for is full operation, is full function, I will be saying if my size has reached to the array dot length which has been given to me by the user, If it has reached the maximum limit, then you can just give me true, that yes, the queue is full, right? Then I am having a simple display function which will display me the values from front to rear, right? Not from zeroth index to the last index of the array. It will display me the values from front to rear, so mind it. So how can I do that? I will just take the current size, whatever it is, in a length. I will take that. I will start my index from the front, and while this length minus minus is greater than 0, so this logic will give me what thing? From front to rear thing, right? From front to rear, it will serve the purpose. Then I can just print the value pointed by the index. Just give me a space here in the same line, and then circularly increase this index as well. Why? Because it can also be the case like after the fourth index it is coming to the zeroth index for printing the value. That is why here also you need to circularly increase, and then you can just give a line break. And in the main function, what we are doing is, for creating the user defined size circular queue, I am just taking the input and passing it to my parameterized constructor and making its object. Then menu driven program, again with the do while loop, you can have the menu, you can perform these operations according to the number specified, right? And you can just take the user input, whatever option they want to implement, and according to that I am having switch, and whatever the case is corresponding, it will run and it will break. So if the element, if there is a case 1, then it will be giving me the enqueue operation, right? I will take the user input and I will pass it into my function for inserting the value. For dequeue operation, I can just call the dequeue function and I can say removed, so that I can also get to know which value is removed. Then in the front function, you can call the front function. Rear, you can call rear. In isEmpty function, we can call the isEmpty function. In isFull function, we can call it. And similarly for displaying, I can say that list is this thing, and then I can display the list so that I can get a better readability. And after that, if you give any other option, then you will be exit from this while true loop, do while loop, right? So let me run this. You will get better understanding how it is getting executed. Okay, so let me give the size as 3. Okay, it will give me the menu. Suppose I do the enqueue operation with 10, again enqueue operation with 20, again enqueue operation with 30. So if I try to display it, it will give me 10, 20, 30 from front to rear. So it is simple. It can also be done in linear queue as well. Let me do something else. What I can do, if my now my queue is full, right? Then if I do enqueue operation with suppose 40, it will tell me false, like you can't insert anything else because your queue is full already. Okay, let me try to do dequeue operation then. So when I have done the dequeue operation, it has removed the 10 from there. And if I try to display now, so only 20 and 30 is there in the list. So now comes the picture of circular queue. If I have deleted the value, and in linear queue I will not be able to add anything else, but in circular queue I can insert one more value. Let us suppose 40. Yes, it is inserted, it is giving me true. So if I try to display it, yes, so after 20, 30, it has inserted the 40 as well. So basically this 40 has inserted in the 0th index, right? But as I am displaying from front to rear, which I have told you earlier, that mind it that I am displaying from front to rear, so you need to keep that in mind. If I try to do the isEmpty operation, then here it will give me false. Okay, if I try to do isFull operation, so here it is giving me true as the queue is full. So I think I have done every okay, so you can also do the front pointer. Yeah, for front and rear pointer understanding, if I do 3, so it is pointing to 20, and if I do 4 with the rear, it is pointing to 40. As here you can see, front is pointing to 20 and rear is pointing to 40. So we are done with the implementation. I can just exit it. So thank you so much for watching my video so patiently. I hope that you have understood the concept of circular queue very nicely. So if you have any doubts, you can just give me a comment. I will be happy to help. And thank you for supporting, guys. Thank you very much.